If 2.417 grams of iron reacted according to the reaction below, how many grams of iron 3 sulfide would be produced? So, I see a reaction and I want to balance it. I look at my irons. I have one on the reactant side, 2 on the products. So if I put a 2, that'll balance my irons. Now I look at the sulfur and I have 8 on the reactant side and 3 on the products. To get these to balance, I need to go for the least common multiple, which is 24. So that's going to mean 8 as a coefficient on my product side and 3 in front of the S8. But that really messed up my irons. I now have 16 irons, so I need 16 on the reactant side in front of the Fe. Many times we get into a habit of thinking that the coefficients in these problems have to be very small. 1, 2, 3, maybe 4 type numbers. Larger numbers can happen. They're not terribly common, but they can happen. So now that we have our reaction balanced, our conversion factors set, we need to go through and start with the actual measurement of 2.417 grams of iron. Now, for chemical calculation, grams are not probably the most useful unit that we can find. Coming up with something a little bit nicer is probably better, and that would be going into from grams of iron into moles of iron. And using Avogadro's number of 6.022 times 10 to the 23rd, it allows us to take all the atomic masses on the periodic table and treat them as gram masses for 1 mole of each substance. So if we go to the periodic table and look for iron, we can see that it has a mass of 56 grams per 1 mole. So if I take that 56 grams from the periodic table, I can now get rid of those units of grams of iron. Now in something a little bit more useful, of moles. But if we have moles of iron up here, we're going to need moles of iron in the denominator of the next step. Now, at this point, we can go from moles to many different units. Grams, atoms, moles of another chemical. Since this problem tells me something about the iron, but asks me something about a different chemical, I want to switch chemicals. I want to go from moles of iron into moles of iron 3 sulfide. The numbers that I get for each of these, for the iron, I use the coefficient for the iron, and for the iron 3 sulfide, I use the coefficient for the iron 3 sulfide. My units of moles of iron have now canceled out, and I still have one more step to do. If we look at the problem, it asks for grams of iron 3 sulfide. Well, right now I'm in moles of iron 3 sulfide, which is close, but not the same. To get from moles to grams, whatever we would add up off the periodic table for the iron 3 sulfide would be how many grams 1 mole would weigh. So 1 mole of iron 3 sulfide would be a certain number of grams of iron 3 sulfide. And if we go to our periodic table, we can see that iron weighs 56 and sulfur weighs 32. But we have more than one iron, more than one sulfur. We have 2 irons and we have 3 sulfurs. Again, just as a reminder, if we say iron 3, we're talking about a +3 charge. But in a compound of iron 3 sulfide, these subscripts tell you how many of that element you actually have. You have 2 irons and 3 sulfurs, regardless of what the charges might be. Try not to confuse the two. So each iron, we said, weighed 56, and each sulfur, we said, weighed 32. So 2 times 56 plus 3 times 32 equals 208 grams per mole. And that goes up here as our conversion factor. That allows us to cancel out the moles of iron 3 sulfide. And since we're now into the units that the question asks for, we're ready to go ahead and do some math. 2.417 divided by 56 times 8 divided by 16 times 208. Again, many different ways of doing the math. You could multiply all the top numbers, multiply all the bottom numbers, and then divide those two when you have them. Perfectly fine. I simply tend to divide by the numbers I find in the denominator and multiply by numbers that I find in the numerator as I go across. For me, I find it a little bit more efficient, but it's not necessarily a right or wrong way of doing it. Simply a little bit more efficient. So, in this problem, I end up with 4.488714286. Since I start off with 3 significant figures, I'm going to round this to just 4.489 grams of iron 3 sulfide.